How you guys doing? So thank you all for coming. This talk is very blandly named the mainstream blockchain game infrastructure. I'm going to try to inform you a little bit of how we build our games and our infrastructure behind the games. How do you make blockchain mainstream? Yeah, so a bit about me. I'm Ben Heidorn. I was at Penn State for 3 years doing my PhD in computer science until Marguerite, our CEO, said, hey, do you want to work on a video game? And I said yes, and then I dropped out. And I fell into cryptocurrency by solving crypto puzzles. And if you know anything about Marguerite's background as coin artist, she is the inventor of the crypto puzzles genre. So it just made perfect sense. Eventually, we started working together. And I bring that up partially because 2 years ago when we announced NEONDISTRICT, I put out this puzzle called the function core that absolutely tortured the entire community. And for a while, I thought that I was crazy and nobody would ever solve it. But on the way here, actually just a few days ago, somebody finally solved it. And it took 748 days. And they got like $7,000 in Ethereum. It's freaking awesome. All right, so a bit about our team. We have a really dope-ass team. It took 2 years to kind of find all the right people, fill in all the pieces. We have great game designers who worked on the precursor to Hearthstone. They're actually, one of them was a Magic the Gathering pro player in the 90s. You can actually find him on MTV. It's really cool. And we have executive producers who worked at Disney for 10 years. Is one of the leading experts in MMOs, so we have a fantastic team. And then we just have really great blockchain engineers, developers. So I'm really proud of everyone who's working on everything that we're doing here. So a bit about the games that we have. If you are familiar at all with Blockade Games, some of these games might be new to you. So the first game we put out was called Pineapple Arcade. It was a series of crypto puzzles. Just came out a few months after we had started the company. NEONDISTRICT is what we are most known for. It's a cyberpunk role-playing game. We had an early version of the game come out in June of last year, and we're going to be doing a full release on Steam in July. We put out Plasma Bears last year. I actually did my talk here last year about Plasma Bears and how we integrated the Transfer Gateway, and a fun little game called Legend of Szabo, which is an homage to Legend of Zelda. And then we have 2 new games coming out. One of them was in development for a while called Cast Mex. We're making an official announcement about that soon. And we have another game coming out very soon called Codename Metaboss. So real quick, I want to show off like some of the cool, dorky little things that we did. This is Legend of Szabo. Like I said, it's an homage to Legend of Zelda, but it has a lot of Bitcoin references to it. So there's bugs. Your hearts are actually nodes in a blockchain. There's all of these weird little references. This is my personal favorite thing, the market-making game. You can never win. I made this in the bottom of the bear market. I was not happy. Some of our puzzles are homages to the puzzles that brought me into the space. One of the bosses is a CryptoKitty. And this is my personal favorite boss, is a bunch of blockchains. And the only way you can beat it is by throwing a double spend boomerang at it, because if you use your fork, you just wind up duplicating the chain. It just starts attacking you. And then you also have to fight Satoshi Light. And then the final boss is a Minotaur with wielding a Bcash symbol. So yeah, so it's a lot of fun. What is the cool thing about the game, though, is not the game itself, it's the technology behind it. This was the first game that you could actually buy your Ethereum tokens using the Lightning Network, and it would immediately mint right to your account. So you could play the game only having Bitcoin, never having used Ethereum at all. And the other really cool thing about it is we let people make their own characters, and you could build your own character, send it to us, and we would mint it to you, and you could play through the entire game with characters that you made. And then another popular game, we put out Plasma Bears last year, and the entire idea behind Plasma Bears is how do you make a full free-to-play game experience with blockchain without any of the user experience problems at all. So right there, someone just logged in using Facebook, and you could actually play the game on Facebook, which made the game really appealing. In the first 2 months, we had over 500,000 NFTs minted, 18,000 bears crafted, and at the peak, we had 600 to 800 people playing per day. And this was without any marketing at all. This was all word of mouth and people sharing tokens with each other. And then we had people playing from like who were 3 years old all the way up to my grandmother, which was freaking awesome to get an email about that. And it wasn't, how do I play this? It was, I'm having a lot of fun playing this, and that's what we want people to do. And then we are a very experimental company. So I wanted to bring up this new project that we just started working on with Alex Amsel, and it is called Mule.wtf. It is a Discord wallet where people don't realize they're actually using a cryptocurrency wallet at all. You register a mule, and then you as a gamer just think of everything inside of a pack mule, and you travel around with it. And we actually just released the white paper. We put a lot of work into this. Please read it and fund our company. Okay, so what I really wanted to talk about, given the time that I have left, is the developer platform that underlies everything. It's not just the games that we're building, it's how do you make mainstream games on blockchain. Now this is a tech-oriented talk, so I do want to get into some of the details, but I'm not going to show a whole lot of code. The whole notion behind the developer platform is we want people to be able to build a blockchain game and deploy it to any game ecosystem at all. It could be Nintendo Switch, it can be mobile, it can be downloadable on Steam. Like, it does not matter where, it doesn't matter which blockchain it is. You should just be able to make a great game. So some of what we offer is we're trying to allow people to analyze all the addresses that a user has and then get immediate information about all the NFTs they have. We have cross-chain asset transfer support. I'm going to be demoing a little bit of that at the end of the talk. Hosting on IPFS, actually splitting the data between chain and just decentralized data outside, and then a whole bunch of other things, including the Lightning Network integration. So this specific talk, I'm going to talk about 3 things that I've personally been working on a lot lately, and it has to do with the custodial onboarding and the offboarding. How do you get people to play a game without knowing anything about cryptocurrency, but then when they start to realize that there's value, they can offload. And then I'm going to talk about the NFT state cache. How do you read the blockchain, give real-time data as quickly as possible, knowing that there are problems with the blockchain where you might have a reorganization and that will change what the state of the data is. And then, of course, I want to talk a bit about the NFT transfers. So after we did a Techstars program last year, I went home and I sketched out, I had in my mind everything that we were going to have to build, and I sketched it all out on a giant whiteboard. And it took us about 8 months, and we finally have all of those pieces working now, which is quite remarkable. And this is probably a more informative version of what I just showed you. This is the entire infrastructure for Neon District, every independent system involved. So where does the platform fit? It is not the blockchain layer. We are not building a blockchain. We're not building the game. We're building everything that interacts between the blockchain layer. Do you write to it? Do you read from it? And then your game servers and the game itself. So everything that has a common API that you should be able to plug into to build your game without having to think about the blockchain aspect of it, that's what we're building. And it is to fulfill this promise that we want to give our users, which is we want them to play a traditional game, get all the value of playing a mainstream game, all the fun, all of the free-to-play aspects, and we want you to get all the benefits of blockchain. We want you to own your assets. We want you to be able to trade them. We want you to be able to have the play-to-earn aspect that we're all promising right now. So what this means is we want to give people a free-to-play onboarding with, for Neon District, all you do is download the game and you start playing. That's it. Other blockchain games, right now, you have to go through the whole user experience issues. You have to download the wallet. You have to own cryptocurrency. You have to understand how this works. And there's a 99+% drop-off rate for that. So we want to completely eradicate all of that. And that allows us to have a revenue model that actually focuses on the free-to-play mechanics that are so popular right now. And the other thing is, it should not matter what kind of game you're building. You can have a game that's entirely on-chain, only playable on OpenSea. Sorry about that, Alex. Or you can have a game that is partially on-chain logic, where you have the contract as most of the logic, and then you have a UI that facilitates a lot of the interactions that you have on-chain. Or what I think is going to happen is most mainstream games, when major players start coming in, they're going to want the NFTs to be on-chain, but they're going to want to control all the game logic elsewhere. That's kind of where I think this is going to go. And I just lost my visual. OK, we're good. All right. Oh, and we basically want the platform to support all of that. So we have first principles that we build everything on. The first is you should always have mainstream onboarding. Nobody should ever have to learn anything that they don't want to learn before they start playing the game. It should just be a game. We want uncompromised quality, which means every bit of complexity should be hidden, it should be automatic, and it should be seamless for the player. And finally, we want free-to-play games that enable play-to-earn. So our entire development thesis, which some people may or may not agree with, is we are building for the mainstream user first. And as the technology gets better, we keep decentralizing it to reduce trust on us, to give people the freedom, basically to have everything, basically to have their cake and eat it too. So seamless user onboarding. Step 1, we let the player play the game before doing anything unfamiliar. Oh no. last year, the entire premise was download the game and start playing. Never even saw a registration screen.
All right, my new shiny Oracle friend. Let's find that bastard.
Oh, shit.
That's the boss. We sold that token to one developer for $22,800, which was quite incredible at the time. Still is today. Step 2, let the player sign up without knowing what a blockchain is. So here we have the registration screen for the NEONDISTRICT portal, which is live right now. It supports all Season 1. You go in, you sign up with a username, a password, you verify through an email, and then as soon as you're in, all you do is just start collecting assets. So right here, you get a free character as soon as you sign up. And we don't mind if people make thousands of emails and then start collecting these characters. They're base characters. You collect them and you grow them over time. This is where play to earn comes in. Step 3, we want people to pay to play the game if they want to, but without owning any crypto at all. So here, we had to kind of do some maneuvering in order to fit the current rules of the current system. We allow people to buy an in-game currency the way that you do in a normal free-to-play game, and you can do it using with Square. So you can use Square, normal credit card, buy as much of this in-game currency you want, and then you can buy loot boxes which contain the actual NFTs inside of them, or you can buy consumables just like a normal free-to-play game. And then what this allows is we have an entire transaction queue and issuance system that runs in the background, and that means no matter how many boxes you buy, you immediately see all of your assets right then and there. And in a queue, they're then minted to you, to your account. Step 4, let the player own their own items when they're ready to do so. Don't force them ahead of time. So here we have an advanced feature, which is you have to enable this manually. It allows you to set your wallets that you have on Ethereum, Loom, Matic Network, whichever we support. You can sign a transaction, or sign a message proving that you own a wallet, and then we can mint directly to your wallets, and we can enable the transfer gateway to those wallets. So basically, you can be a normal player, just playing a game. You don't have to think about the blockchain aspect at all. It will still all be on chain in your custodial wallet, but when you're ready, or even the moment you sign up, you can just start collecting the assets directly to your ownership. So, moving on to the next point, the fundamental question of everything we build, how do you build a reliable infrastructure given all the trade-offs of blockchain? So there are some fallacies about the infrastructure that we're working with. The first is that we assume maybe blockchain is reliable, that the network is always available, that latency is 0. We know this is not the case. Block times exist. The minimum that you have to wait on Ethereum is 15 seconds. Well, not minimum, but the average is 15 seconds. Bandwidth, absolutely not infinite. We have to worry about not only how much data you can transfer, but how much you can fit into a block. The network is secure. That's fairly true. That's fairly true, actually. Topology doesn't change, not at all. Everything is completely different. Every system is completely different. There's even parity and geth and all the different nodes that you can run. One administrator, not a clue. Transport cost is 0, obviously not. You have to pay for every single transaction. And of course, network homogeneous is the same as the previous one. So the CAP theorem is what we think about when we think about distributed networks. There's a theorem where you have to pick more or less 2 out of these 3 principles. You can have a consistent system where every read always gets the most recent write. You can have availability where you always get a non-error response, meaning every time you read, you should always get an answer, but it might not be the most recent one. And finally, your partition tolerance. What happens when the network starts to break down? What happens when nodes go offline? The way that blockchains are designed, most of them are incredibly strong in partition tolerance, not IOTA, but Ethereum and blockchain, or Bitcoin, definitely. And that's the whole purpose of Bitcoin, is you have to be able to tolerate when people are attacking the network. When forks happen, the network should always remain live. And that means you also have availability. But what you do not have is consistency. There are trade-offs here. So depending on the length of time in which you're looking at the blockchain, do you have eventual consistency, meaning eventually you'll get the most recent right? Or do you have strong consistency, meaning you always get it? In blockchains, it is probabilistic. After n blocks happen, you eventually approach strong consistency. And this works for pretty much everyone. building DeFi apps, building anything that depends on blockchain directly. But if you need immediate data, the model is eventual consistency because you have reorganizations. Transactions can move around. They can be dropped entirely. So the fundamental problem that we have here is it is fine for fully decentralized, high security and latency tolerant applications to use blockchain out of the box. But game companies cannot do that. We need immediately and available consistent data for our users right away. So how do you handle that? You have to understand the nature of blockchain, and you have to make a cache that can adapt to it. So what we're doing is providing immediate data in our cache, and then we separate the data from the views, from all the side effects of that. So if you think about when you process data and you have results that come out of that, there are always going to be side effects. You have to build your system such that the side effects are minimal or non-existent at all. So here's an example. This is a script trying to find when a reorganization happens. I was reading the Tether USD contract here, and here you can see a bunch of transactions that came in the previous block were all moved to another block. It actually happens twice in a row. So we have a reorganization happening in real time, and it doesn't just mean that you're missing transactions, or it doesn't just mean that they're moving around, you're also missing them. And that's not good, because you could be reading everything from a certain block height, and if you lose those transactions, that is data that you do not have available to your system. It breaks everything. So you have to handle both simultaneously. So what we have now is a system where we will read in the blockchain cache, and we will always read it in for the last n blocks. And the n blocks is going to be where you can eventually assume, for the most part, that you have strong consistency. So here we're reading in from 2 chains, Loom base chain and Ethereum mainnet, and there are 7 contracts being read in right away, or however many there are there. And then, this is the boring stuff. I apologize. And then here we're actually showing all the assets that people own. So here are some random addresses that are just being brought in from the cache. And then we can actually pull in the count of assets that they have across all the contracts that we're watching at this time. Actually, I don't have much time, so I'm just going to skip right past that, but you can kind of get where I'm going with this. So how do you scale this? The objective is for mainstream users, and mainstream games have millions of players all the time. This is not a phenomenon. These are not highly successful games. These are normal, independent games. They just happen to have millions of players all the time. So how do you scale that using current blockchain technology where a few thousand people break the network? So there are ways you can do this. You can do this on the protocol level, which is what a lot of people are working on here at ETHDenver, or you can work on the application level. And frankly, we are application developers, we're game developers. That is what we have control over. We cannot control the protocol. We let other people do that who know much better than we do. So what we can do there is minimize the contract complexity so that we can manage more transactions at the same time. And we also do things like minting on demand. So there are certain considerations that you have to have here. For Ethereum, there's a large number of slow requests to pull information if you're pulling directly from the blockchain. You have to do costed transaction signing. You have to pay for everything. You have to wait for everything. You have to have users manage their own private keys. These are all the drawbacks of using a mainnet blockchain right now. But you can scale by using a sidechain like Matic or the Loom network, and that will give you zero cost to your users, where the developers are paying a fee just to support the network. It means that they get the immediate convenience. They get incredibly short block times. Everything feels like it should in a normal game. And in order to support bridging those two together, you need to give people all the benefits of using a sidechain and all the liquidity benefits of using a mainnet, and that's where you have to provide cross-chain transfer protocols. The one that we're working on right now is a transfer gateway, and we're trying to make it as decentralized and trustless as possible. So why a transfer gateway? Well, for one thing, we're not a blockchain. We have to build things that will work across multiple networks. We only verify the cross-chain transfers of our own tokens, and the only parties involved are the player and the gateway. So we minimize the risk profile of using the transfer gateway. And finally, it is not required to use. So if you don't want to use what we are providing you, if you want fully trustless systems, you can use Plasma Cash. You can use the systems that exist already. So here's an example. See how much more time I have. I've got a few minutes. So this is an example of the system that's live right now. We're going to push this out to production probably in a few weeks when I'm done coding the update to the cache that I was showing you earlier. Here, you can log in using your wallet, and you can pick the item that you want to transfer. And this is all on the mainnet, by the way. This is all live. So this is the real-time transferring happening on the Loom network side, going into the transfer gateway contract. And then there's an oracle that just reads the data and signs a proof saying, yes, I own the asset now. I can release it on the other side. So now here you have the person, the owner of the asset, now manually paying the transaction while submitting the data for the signature and the proof. And when they do this, and of course I abbreviated this because you do have to wait a bit, you immediately get your asset. So here we have our sledge feed drone. It's now available on OpenSea. And you can go over there, and now you can trade it freely. So what happened? On the high level, we had a token approval. You have to give the contract the ability to transfer on your behalf. Then we had the deposit. This is where the magic happens. The deposit emits all the information required so that you can have the signature, which is step 3. The oracle reads the data, says, yes, I own the asset, and provides you with the proof, which then you manually release on the other side. But it doesn't just have to be you. You can have anyone release this for you. So you can use the Ethereum gas station network. You can have just your friend submit this for you, and it will securely end up in your wallet, and you don't have to pay for it at all. So this is the same process going backwards. There are 2 items here that are on the Ethereum chain. And you can connect your wallet, and you can read all of the items that you have, and you can pick the one that you want to transfer over. Sorry, I should have made these videos a little faster. I thought I was going to speak slower, and I forget that I talk really fast when I give a talk. So here, now you're actually doing those transactions that happen on the Loom network side automatically for you. Oh, do I have to cut it? Cool. Now this is the last one. Yeah, so here's the deposit. And then you confirm it. Once again, you pay for both those transactions, and the rest of this all happens on the Loom network side. Yep. So then you finalize, the oracle signs it, the Loom network side will then mint directly back to your account. It's done. When you connect to your wallet again, you'll see the token no longer exists in your wallet. But when you go to view the asset, it's now back in the sidechain. So that Ethereum logo that was on the right-hand side of that is gone now, and it's back in your wallet. So that's the entire talk. That's everything we're working on right now. There's a crap ton of stuff, and if you want to ask any questions or talk more afterward, just come find me. Thanks.